OSIRIS-REx has been in orbit around the asteroid Bennu for around a year now. Bennu is the smallest object ever orbited, and as a result, OSIRIS-REx orbits only several hundred meters above its surface. Being so close to the asteroid means it can examine its entirety in minute detail. So what has it discovered and seen so far, and what does the mission still have to do? I'm Alex McColgan and you're watching Astrum, and together we will explore the surface of Bennu, talk about any special findings that have come up so far, and investigate what's coming up next for this special mission. As I mentioned, one of the most unique things about this mission is the fact that OSIRIS-REx is orbiting Bennu, which is only 500 meters wide. A 500 meter wide object barely has any gravity at all, which means one orbit of Bennu takes 62 hours at an altitude of 1.75 kilometers. However, orbiting Bennu was necessary to map its surface accurately. As the spacecraft orbits and the asteroid rotates, OSIRIS-REx is scanning the surface, creating the highest resolution map of any celestial body to date. This detailed examination is to find the best landing site for OSIRIS-REx, which is actually a sample return mission. Scientists want to retrieve 60 grams from the surface of Bennu and return it back to Earth in pristine condition. While there are a lot of meteorites that land on the surface of Earth, and we have many samples, these meteorites pass through our atmosphere, heating up to incredible temperatures, which alters the delicate materials in the meteorite. Upon impact, they are also then exposed to the surface of Earth, making it hard for scientists to distinguish what was there from before and after the impact. A sample directly from an asteroid, protected in a box from contamination which occurs during the re-entry process, can give a much greater insight to the nature of asteroids than anything we have observed before. With this sample, scientists will be able to search for organic compounds like amino acids, hydrated materials like clays, and other substances that would otherwise be hard to detect. But has OSIRIS-REx found anything interesting during its preliminary scans? OSIRIS-REx isn't just taking photos of the asteroid, but it is also mapping the global properties, chemistry, and mineralogy of this primitive carbonaceous asteroid to characterize its geologic and dynamic history, to provide context for the return samples. It's doing this to help pick the best site for the sample return part of the mission. Scientists are looking for the most geologically interesting site that can provide the most interesting sample. Spectroscopic surveys have already revealed that there are hydrated materials, or in other words, clays on the surface of Bennu. This is significant. Clays contain water, and Bennu was not the type of body where scientists expected to find traces of water. Scientists are still of the belief that a body as small as Bennu could never have held its own water, but what this does imply is that liquid water was likely present on the body Bennu would have originated from, and all that remains of it is what has been locked away in these clays. Scientists had a rough idea of what Bennu looked like before OSIRIS-REx even arrived, thanks to radar imaging from ground-based telescopes. However, what they didn't expect is just how much the surface is covered with large boulders. Many asteroids have been described as rubble piles in the past, but I don't think anyone was expecting it at this scale. Just to give you a sense of scale, the largest boulder on the surface is 20 meters high and about the size of a football field. Other boulders you see here are about the size of a horse. This makes picking a landing site a little tricky when ideally you are looking for a patch roughly 25 meters in diameter containing particles no bigger than a centimeter, so your sample collector can retrieve a sample safely. However, 4 smaller landing sites were eventually chosen, named Osprey, Kingfisher, Nightingale, and Sandpiper. Even though they are smaller sites than originally hoped for, the sites are relatively free from boulders. Scientists have had to adjust and refine their plans to make sure OSIRIS-REx will hit its mark, as the difficulty of the maneuver is exasperated by the small size of the landing sites, which are no bigger than a few car parking spaces, with large and dangerous boulders surrounding them. It won't be long before the final sample site is picked, and within a few months of that, mission controllers will attempt the sample collection. All being well, they'll be successful on their first attempt, but they do have the fuel to try again should they not get anything the first time, and if they don't crash. Considering Bennu is seemingly an inactive pile of rocks floating in space, Bennu also surprised scientists greatly when OSIRIS-REx spotted some dynamic activity on the asteroid. Occasional ejection events were spotted, where some material was flung away into space. Some of these particles were even captured in orbit around the asteroid for a few orbits, before eventually returning to the asteroid's surface. This is likely due to the fast rotation of the asteroid, and OSIRIS-REx has already been able to detect that this rotation is speeding up very gradually due to the Yorp effect.